A single stone block can outweigh 3 blue whales. How did ancient engineers move these colossal stones without any modern machinery? This video uncovers the brilliant minds behind these impossible structures, the engineers of antiquity who moved stones modern cranes cannot lift. You will discover the forgotten techniques and profound secrets that completely reshape our understanding of human history. We will explore how they quarried 1,000-ton monoliths and positioned them with millimeter precision. What does their timeless ingenuity reveal about our own potential today? The Great Pyramid alone contains over 2 million stone blocks, each weighing an average of 2.5 tons. But this is merely the beginning. At the ancient site of Baalbek in Lebanon, we find the stone of the pregnant woman, a single block of limestone estimated to weigh over 1,000 tons. To put that into perspective, that is heavier than a fully loaded jumbo jet. The fundamental question these stones scream across the millennia is not just why they were moved, but how. How do you quarry a skyscraper's worth of stone from a bedrock quarry? How do you transport it, sometimes for miles, across rugged terrain? And finally, how do you lift it and place it with a precision that still baffles modern engineers? They had no steel cables, no diesel engines, no hydraulic cranes. Their toolkit was seemingly primitive, consisting of stone hammers, copper chisels, wooden levers, and ropes. This is where the mystery deepens from a simple question of manpower to one of mind power. Experts like engineer Christopher Dunn have meticulously studied the microscopic tolerances and perfect angles of these structures. He and others point out that the precision fitting of these megaliths often suggests a level of geometric and engineering knowledge that we do not typically attribute to ancient civilizations. It is as if a sophisticated technical understanding was applied, an understanding that may have been lost in the sands of time. When we look at these sites from Egypt to Peru, from Stonehenge to Easter Island, we start to see common threads. They are frequently aligned with celestial bodies, the sun, the stars, with an accuracy that implies deep astronomical observation. They are often built upon or from specific geological features, chosen for the unique properties of the stone itself. This points to a unified global principle, a shared worldview among these ancient engineers. They saw their world as an interconnected whole, where the earth and the heavens were part of a single grand design. Their technology was not separate from this philosophy, it was an expression of it. To understand how they moved mountains, we must first try to understand how they thought. The sheer scale of this challenge becomes almost unimaginable when we try to picture it. Moving an 800-ton block of stone is not merely a task of brute force, it is a high-stakes logistical nightmare. Modern engineers calculate that dragging such a weight on a simple sledge would require the coordinated effort of thousands of people, a human chain so long it would be impossible to manage effectively. So how did they overcome the crushing force of friction? Ancient Egyptian wall carvings provide a vital clue. They depict colossal statues being transported on massive wooden sledges, with a figure standing at the front pouring a liquid onto the path ahead. For a long time, this was thought to be a ceremonial act, but experimental archaeology has revealed a stunningly simple genius. It was not a ritual, it was physics. By wetting the sand or clay in front of the sledge, they created a slick, firm surface that dramatically reduced friction. The sledge would glide more easily, turning an impossible pull into a manageable, albeit still monumental, effort. Yet even this clever solution only works on flat, prepared ground. How did they move these stones across miles of uneven, often hilly terrain without shattering them? This is where the mystery truly deepens. Some researchers propose intricate roller systems made from felled trees, a method that requires an immense amount of timber and constant repositioning of the logs. Others suggest a pivot and lever technique, where workers would repeatedly lift one end of the stone, insert a wedge, and slowly rock it forward in a painstaking, inch-by-inch procession. But when modern teams have tried to replicate these methods with stones a fraction of the weight of the Baalbek monoliths, they often fail. The stones crack under their own immense pressure, or the logistical coordination required proves overwhelming. This stark gap between our experimental recreations and their undeniable success forces a profound question. Were these ancient engineers using a lost principle of physics, a forgotten understanding of leverage and weight distribution that we have yet to rediscover? Their reality seems to defy our most careful assumptions, pointing to a level of human coordination and resource management so advanced it challenges the very timeline of human innovation. Moving from transport to its very origin, we face the raw beginning of the mystery. How do you begin to separate a 1,000-ton block from the living bedrock itself? The quarries of Aswan in Egypt offer a frozen moment in time. Here lies the unfinished obelisk, a colossal needle of granite that cracked and was abandoned in situ. Its sides are scarred with the unmistakable marks of dolerite stone pounders. Teams of workers would have swung these heavy balls of dolerite, a stone harder than granite, to literally pulverize the rock along a predetermined line. It was a monumental act of persistence, a symphony of controlled violence that would have taken immense time and effort. But this method, while effective for creating the rough shape, does not fully explain the mirror-smooth surfaces and impossibly sharp corners found on finished monuments. For that, something else was required. The sheer precision in harder stones like granite and diorite is what truly baffles experts. The surfaces are often so flat and so perfectly joined that they suggest a level of finishing that dolerite pounders alone could not achieve. This has led to persistent speculation about lost technologies. Could the ancients have possessed some form of diamond-tipped tooling, a secret method for cutting and polishing that has since vanished from the historical record? Other, more experimental theories propose the use of thermal shock. Imagine heating a specific line on the granite with fire, then rapidly cooling it with water. The sudden contraction would cause the rock to fracture cleanly along the heated seam. Another fringe idea suggests the use of sonic vibrations, using precisely tuned sound waves to find a resonance that would cause the stone to split along its natural crystalline plane. While these ideas sound like science fiction, the physical evidence sometimes seems to demand answers that lie outside our conventional understanding. This mastery of stone was not isolated to Egypt. Travel across the world to the Inca citadel of Sacsayhuaman in Peru. Here, massive stones, some weighing hundreds of tons, are assembled into walls with such insane precision that the joints are virtually invisible. You cannot slip a razor blade or even a piece of paper between them. The blocks are polygonal, interlocking like a three-dimensional puzzle, with complex angles and curves that fit together perfectly without a single drop of mortar. This achievement is so advanced that it seems to defy the very tools we believe the Incas possessed. The common thread running through these distant sites is not just a catalogue of tools, but a profound and intimate knowledge of geology itself. These engineers were not just workers, they were readers of the stone. They understood how to select the perfect block by identifying natural fault lines and grain directions within the bedrock. They worked with the mountain, not just against it, using its inherent weaknesses as their starting point. The quarrying process was an act of deep harmony with the natural world, a conversation between human intention and the character of the earth. This sophisticated understanding of materials leads us directly to the next, even more baffling stage of the process. The challenge of lifting these stones is as immense as their weight. Visualize a single lintel stone at Stonehenge, a 70-ton slab that needed to be raised over 30 feet into the air to crown the massive uprights. How do you achieve such a feat with nothing but ropes, logs, and human muscle? The most accepted theories point to ramps, levers, and counterweights. The Greek historian Herodotus wrote of wooden machines used to lift the blocks of the Great Pyramid, ingenious devices that have long since rotted away, leaving no physical trace for us to study. This absence of evidence is the heart of the puzzle. For the pyramids, one school of thought suggests the Egyptians constructed vast, spiraling ramps that coiled around the rising structure, a continuous roadway for workers to drag stones upward. Others argue for a single, massive straight ramp, or perhaps a zigzag design that reduced the incline. Each theory has its merits and its flaws, demanding staggering amounts of material and labor that are difficult to comprehend. At Stonehenge, the method might have involved a different kind of ingenuity. Picture a simple but powerful frame structure made from giant timbers. With a complex system of ropes and pulleys and teams of people pulling in unison, they could have slowly walked the stone into a vertical position. Another method involves creating a lever and fulcrum system, slowly raising one end of the stone bit by bit, packing timber underneath until it stands upright. But the true marvel is not just the lift, it is the final placement. How did they achieve that millimeter precision, ensuring that the 70-ton lintel dropped perfectly onto its supports without shattering? This speaks to a mastery of surveying and leveling that seems almost supernatural. They must have used water levels for perfect horizontals and sighting tools aligned with the stars to ensure celestial accuracy. The placement was a final, breathtaking act of coordination, where the brute force of the lift met the delicate touch of the geometer. This entire process, from quarry to final position, was a symphony of physics and mathematics, a practical application of principles we still use today, but executed on a scale that pushes the boundaries of human capability. This obsessive pursuit of perfection forces a deeper question. Why did ancient cultures invest generations of labor and unimaginable effort into achieving such flawless precision? The answer lies in the realization that these were never merely functional buildings or simple monuments. They were profound cosmological statements carved in stone. Take the Great Pyramid of Giza. Its four sides are aligned with the four cardinal directions with an error of less than 1/15 of a degree. This is not just impressive construction, it is a deliberate act of orientation, connecting the structure to the very axis of the planet. For the Egyptians, the pyramid was a machine of resurrection, a ramp for the pharaoh's soul to ascend to the stars. Its alignment was not for show, it was a spiritual and astronomical necessity, a physical bridge between the earth and the heavens. Travel across the world to the Andes Mountains of Peru. At Machu Picchu, the architecture does not simply sit on the land, it becomes one with it. Temples and terraces are carved to frame specific mountain peaks, which were themselves considered sacred deities or apus. The Intihuatana stone, the so-called hitching post of the sun, was precisely shaped to cast specific shadows during the solstices, marking the sun's journey. Here, engineering was an act of reverence, a way to harmonize human existence with the divine rhythms of the natural world. Researchers like John Anthony West argued that this global phenomenon points to something far beyond advanced stonemasonry. He saw it as evidence of a lost science, a sophisticated understanding of natural laws that we are only beginning to rediscover. In this view, the precision of these structures was not just symbolic. It was functional. The perfect joints and specific alignments may have been designed to manipulate subtle energies, to create unique acoustic resonances for ceremonial purposes, or to amplify the Earth's own magnetic fields. The stones themselves were not just building blocks, they were components in a vast, sacred technology. The motive behind the millimeter-perfect fit was not purely technical pride. It was about creating a seamless whole, a structure without weakness both physically and spiritually. A perfect joint meant no energy could escape, no malevolent force could enter. The entire edifice became a single, energized entity. This reveals a civilization where the engineer and the priest were often the same person, where the act of building was a form of prayer, and where every stone laid was a word in a silent, enduring dialogue with the cosmos. These echoes across continents form one of history's most compelling patterns. In the high Andes of Peru, the polygonal walls of Sacsayhuaman lock together in a chaotic, earthquake-resistant jigsaw. Then travel across the world to the citadel of Mycenae in ancient Greece. Here, the Lion Gate is framed by cyclopean masonry, massive limestone blocks so perfectly fitted they also required no mortar. Two cultures separated by vast oceans and thousands of years arrived at the same brilliant architectural solution. How is this possible? The mainstream archaeological view favors convergent evolution. This is the idea that different human minds, when faced with the same fundamental problems of stability and seismic survival, can independently invent similar solutions. It is a testament to universal human ingenuity, yet the sheer specificity of these techniques, the way these polygonal blocks interlock with such complex, multi-angled joints, makes others wonder. Could there be a different explanation? Some researchers, like Graham Hancock, propose a more radical idea. They suggest a lost mother culture, a sophisticated global civilization that existed at the end of the last ice age, whose knowledge was scattered and preserved by survivor cultures around the world. This is a controversial theory, but it speaks to the powerful, almost uncanny feeling these sites evoke. The evidence is not just in the shapes, but in the materials themselves. The ancient Egyptians chose granite, an incredibly hard igneous rock, for their most enduring monuments. High in the Andes, the Inca builders worked with andesite, another brutally hard volcanic stone. Each material posed a unique and immense challenge. Granite is full of quartz crystals that rapidly dull copper tools. Andesite is similarly tough and abrasive. For cultures supposedly limited to simple stone and bronze tools, the ability to shape, dress, and polish these rocks to a mirror finish seems to push the boundaries of possibility. This points to a shared, deep understanding of material science. They knew which stones would last for millennia and developed the relentless patience and skill to master them. Yet for every pattern, there is a startling anomaly that refuses to fit. Consider the ruins of Pumapunku in Bolivia. Here, the stonework moves beyond interlocking blocks into something that feels unnervingly modern. The andesite and granite blocks are not rough-hewn. They are precision-cut into complex geometric forms with razor-sharp edges, perfect right angles, and intricate recesses that look less like hand-chiseled stone and more like components manufactured on a machine tool. Some blocks have identical H-shaped channels and precise drilled holes that seem to repeat like parts on an assembly line. The level of geometric planning and execution is so advanced that it feels completely detached from the methods used at other contemporary sites. These anomalies fuel intense debate. Do they represent the pinnacle of a lost stonemasonry tradition, a secret technique that has since vanished? Or do they point to something else entirely, a technology that we would not expect to find in the deep past? These questions linger in the air at Pumapunku, challenging every comfortable assumption about the timeline of human innovation and leaving us to wonder what other secrets are still buried, waiting to be unearthed. The seemingly random placement of stones at Sacsayhuaman or the perfect angles of the Great Pyramid begin to make a different kind of sense when you look through the lens of mathematics. These structures are not just piles of rock, they are three-dimensional equations. The builders were not merely stacking blocks, they were encoding fundamental truths of the universe into their work. Consider the Great Pyramid of Giza once more. Its base perimeter, when divided by twice its original height, gives you a number extraordinarily close to pi, the mathematical constant that defines the relationship between a circle's circumference and its diameter. This is not a simple coincidence that arises from any random set of dimensions. It is a specific, deliberate relationship. Furthermore, the proportions of the pyramid's faces align with the golden ratio, approximately 1.618, a number found throughout nature in the spiral of a nautilus shell or the arrangement of seeds in a sunflower. This ratio is often associated with a sense of perfect harmony and beauty. The early Egyptologist Flinders Petrie spent years meticulously surveying the pyramid, and his precise measurements first brought these mathematical harmonies to light. He concluded that the builders must have possessed a profound and practical knowledge of geometry, a knowledge that allowed them to translate abstract numbers into physical reality on a colossal scale. This mathematical genius was a global phenomenon. Far across the world, the Maya of Mesoamerica designed their temples and cities with an equally sophisticated grasp of numbers. Their buildings were precisely aligned with celestial events, like the path of the sun on the equinoxes or the cycles of Venus. To achieve this, they needed advanced astronomical calculations and a standardized system of measurement. They likely used simple but brilliant tools like observing the changing lengths of shadows cast by a gnomon, a vertical stick, to track the sun's movement throughout the year. Or they used water levels to create perfectly flat plains for their foundations over vast distances. For these ancient engineers, mathematics was never an abstract subject confined to scrolls. It was a practical, living tool. It was the invisible blueprint that guided every decision from the quarry to the final, breathtaking placement. The geometry was woven directly into the stone, a permanent record of a civilization's dialogue with the cosmos. This seamless fusion of calculation and construction hints at a unified system of knowledge, one where the spiritual and the scientific were not separate realms, but two sides of the same, perfectly cut stone. The tools that shaped these granite giants should have been impossible to use. Conventional archaeology tells us the Egyptians relied on copper chisels and dolerite stone hammers. But when modern craftsmen try to replicate their work using these tools on hard stones like granite or diorite, the results are telling. The copper chisels bend and dull almost immediately upon contact, barely scratching the surface. The stone hammers can pulverize rock through relentless pounding, a technique evidenced by the dolerite balls found at quarry sites. But this method is brutally slow and cannot account for the intricate hieroglyphs, the mirror-smooth finishes, or the perfectly straight saw cuts found on sarcophagi and statues. There is a glaring disconnect between the tools we have found and the quality of work they supposedly produced. This gap in the historical record is where the mystery truly ignites. Some researchers point to undeniable evidence of advanced machining. In Egypt, we see core samples drilled from granite that show spiral grooves that suggest a drill bit was fed into the stone under immense, consistent pressure, removing material at a rate that simple hand turning could never achieve. Other stones bear the marks of saw cuts, cut so straight and narrow they imply the use of massive saws armed not with teeth, but with an abrasive slurry. This slurry, a mix of wet sand and a harder mineral like corundum, could have been used with copper blades. The copper itself was too soft to cut the stone, but it acted as a carrier for the hard, sharp, abrasive particles which did the actual cutting. This would have been a slow, laborious process, but it would work. It explains the saw marks, but it does not fully explain the sheer speed and scale of the operation. How did they produce so much perfectly finished granite work in a single lifetime, let alone a single reign? This question becomes even more pronounced when we cross the ocean to South America. The Inca are known to have used bronze tools, an alloy even softer than copper. Yet they shaped andesite, a volcanic rock as hard as granite, into blocks with beveled edges and seamless joints. The conventional abrasive method seems insufficient to explain the fluid, almost organic way the stone appears to have been worked. This has led to more speculative yet fascinating theories. Could the ancients have discovered a lost alloy, a metallurgical secret that produced a metal far harder than any bronze or copper we have found in the archaeological record? Perhaps the tools themselves have not survived, corroded away by time. Even more intriguing are the persistent legends and modern experiments surrounding plant-based solvents. Certain plants in the Amazon, like the sap from the euphorbia plant, are known to have corrosive properties. Could a similar, lost botanical knowledge have been used to create a chemical paste that literally softened the surface of the stone, allowing it to be molded and shaped like clay before it rehardened? Other theories propose thermal methods, using focused heat to expand and weaken specific areas of the rock, making it easier to work. The tool mystery forces us to expand our view of ancient capability beyond simple brute force. It suggests a holistic understanding of physics and chemistry, where sound, heat, and organic chemistry were all part of the engineer's toolkit. The true tool may not have been a physical object at all, but the applied knowledge of natural law itself. The mystery of the stones is ultimately a mystery of the people. How did ancient societies mobilize and sustain a workforce large enough to move mountains of rock, not for a season, but for generations? The romanticized image of countless slaves whipped into submission is being dismantled by the evidence itself. Near the Giza Plateau, excavations have revealed tombs not of slaves, but of skilled laborers. These workers were fed a diet of bread, fish, and beer, and received medical care for their injuries. They were not driven by the lash, but by a complex system of compensation, paid in food, goods, and perhaps the profound honor of participating in a project of cosmic significance. The real magic was not in alien technology, but in human organization. A project like the Great Pyramid required a society to function like a single, living organism. It demanded the seamless coordination of thousands of people, each with a specialized role. There were the quarrymen who understood the grain of the stone, the ramp builders who engineered the ascent, the sailors who transported materials along the Nile, and the surveyors who ensured every block met its mark with celestial accuracy. This was a symphony of labor conducted with breathtaking precision. This logistical genius was a global phenomenon. Consider the sprawling complex of Angkor Wat in Cambodia. Its construction required the movement of millions of sandstone blocks, each weighing up to 1.5 tons, from a quarry over 25 miles away. The coordination of this effort across such a vast area implies an administrative system of staggering sophistication. How did they track it all? They likely used an early form of inventory control, perhaps a system of tokens or inscribed tablets, a primordial blueprint for project management that ensured every stone was accounted for from quarry to final placement. The sheer scale of these endeavors reveals a profound truth about these ancient civilizations. Their power was not just in the authority of a king or pharaoh. but in the shared belief system that united every level of society. A common spiritual vision provided the fuel for this immense communal effort. The pyramid was not just a tomb for a god-king, it was a national project that gave purpose and structure to an entire civilization. This ability to organize human energy on such a monumental scale is perhaps their greatest achievement. It demonstrates that these wonders were not handed down by outside forces, but were built by the collective will, ingenuity, and collaboration of humanity itself. The true monument is not the stone, but the society that could dream it into existence. This deep understanding of human organization was matched by an equally profound mastery of the natural world. The greatest ancient engineers were not just builders, they were master geologists and environmental scientists. Their genius lay in reading the landscape itself, exploiting its inherent strengths and compensating for its weaknesses with astonishing foresight. The Egyptians demonstrated this principle perfectly. While they used local limestone for the core of their pyramids, they specifically sought out granite from quarries in Aswan, over 500 miles up the Nile, for the most critical structural elements. They understood that granite's immense hardness and durability were essential for the inner chambers, sarcophagi, and lintels that needed to bear colossal weights for eternity. This was not a random choice, it was a deliberate selection based on a deep knowledge of material properties. This environmental wisdom shines even brighter in the rose-red city of Petra. Here, the Nabatean builders did not quarry stones to assemble their magnificent facades. Instead, they carved the entire city directly from the living sandstone cliffs. They used the rock's natural strata to their advantage, placing the most critical structural elements within the strongest, most stable layers of stone. They became one with the mountain, shaping it from the inside out. This intimate knowledge extended far beyond simple stone selection. These master builders likely conducted what we would now call extensive site surveys. They studied water tables to ensure their foundations would not flood or become unstable. They observed wind patterns to orient structures for natural ventilation or protection. They even designed with seismic activity in mind. The Leaning Tower of Pisa is a famous example of a foundation flaw, but its continued survival is a testament to medieval engineers who, understanding the soft, compressible ground, deliberately built the upper floors with a slight curve to counterbalance the tilt, a correction that has kept it standing for centuries. This holistic approach even influenced the very purpose of the materials. The smaller bluestones at Stonehenge were transported with immense effort from the Preseli Hills in Wales, a journey of over 140 miles. Why go to such trouble when local stones were available? Geological analysis suggests the bluestones were prized for their unique properties. When struck, they produce a distinct metallic ringing sound, leading to theories they were chosen for their acoustic qualities in rituals. Other research points to long-held beliefs about their healing powers. The builders were not just moving rock, they were transporting a specific, powerful resource imbued with meaning. Their entire philosophy was one of harmony. They worked with nature, not against it, creating structures that were sustainable not through force, but through intelligent adaptation. This ancient wisdom, born of careful observation over generations, is a powerful lesson that modern engineers are only now beginning to fully appreciate and reintegrate into our own designs. The stones themselves seem to hold a secret frequency, a silent song waiting to be heard. Beyond their immense weight and perfect geometry, many of these ancient structures possess a hidden sonic dimension. Step inside the hypogeum of Hal Saflieni in Malta, an underground labyrinth carved from solid limestone. Here, in the so-called oracle chamber, a deep voice spoken into a specific niche does not just echo. It resonates, amplifying into a powerful, bone-shaking vibration that seems to fill the entire space. This is not a random acoustic quirk. The chamber was sculpted to create this exact effect, a feat that required an advanced understanding of sound waves. Across the world, researcher Paul Devereux has meticulously documented how stone circles in Britain act as natural amplifiers. Sound created within the circle is contained and focused, while noise from the outside world is muted. This creates a distinct sonic environment, an auditory temple that could have been used for rituals, communal gatherings, or even sound-based healing practices. The ancients may have been manipulating a sense we rarely consider in archaeology, using architecture to conduct the very air around them. This sonic engineering might have had astonishingly practical applications as well. Modern experiments have demonstrated a startling phenomenon. When a heavy object is placed on a surface coated with a thin layer of liquid and subjected to high-frequency vibrations, the friction is dramatically reduced. The object almost glides. Could this principle have been known thousands of years ago? Imagine teams of workers not just pulling ropes, but also surrounding a massive stone block with chanting, drumming, or the targeted sound of specific instruments. The resulting vibrations could have made the impossible possible, turning a 1,000-ton monolith into an object that moves with surprising ease. This idea moves beyond theory when we look at ancient Egypt. Certain chambers within the Great Pyramid, built with specific dimensions and from specific types of granite, are calculated to resonate at particular low frequencies, frequencies known to affect human brainwave patterns. These infrasound tones can induce states of deep relaxation, heightened focus, or even trance. The engineering was not merely structural, it was psychological and spiritual. The pyramid was not a silent tomb, but a resonant instrument designed to alter consciousness and enhance ceremonial experiences. This reveals a technology that was profoundly holistic. For these master builders, a wall was not just a barrier, it was a sound reflector. A chamber was not just a room, it was a resonant cavity. They were not only shaping stone, they were sculpting silence and orchestrating vibration, harnessing invisible forces to serve both the practical needs of construction and the profound depths of the human spirit. These structures were not mute monuments, but libraries of stone, their every angle and proportion infused with layered meaning. The Great Pyramid was far more than a royal tomb. In the Egyptian creation myth, the world began as a primordial mound, a single hillock rising from the infinite, dark waters of chaos. The pyramid, with its sharply defined sides reaching for the sun, was a deliberate recreation of that sacred first land, a machine designed to channel the forces of creation for the pharaoh's rebirth. Its geometry was a spiritual technology. This same principle echoes across the globe at Stonehenge. The massive trilithons are not randomly placed. They form a celestial calendar, their arches perfectly framing the rising sun on the summer solstice and the setting sun on the winter solstice. The entire circle marks the eternal cycle of life, death, and rebirth, a stone declaration of humanity's connection to the cosmos. In India, this storytelling reaches an astonishing level of detail. The intricate carvings covering temples like Khajuraho are not merely decorative. They are a vast encyclopedia of existence, depicting everything from earthly pleasures and daily life to grand cosmic events described in ancient scriptures. The very proportions of these temples are calculated using mandalas and yantras, complex diagrams of sacred geometry that map the universe. The engineer and the sculptor worked in unison, carving the divine into every surface. This transforms our understanding of a site like Baalbek. In a region scarred by frequent and powerful earthquakes, the sheer mass of its 1,000-ton foundation stones takes on a new meaning. They were not just an engineering solution, but a symbolic one. Placing such unimaginably heavy, immovable blocks at the base of a temple dedicated to the gods was a physical prayer for stability. It was a testament to divine protection, a declaration that the house of the god was as unshakable as the bedrock itself. To move these stones was an act of faith, and to place them was a ritual. Decoding this symbolism requires us to step into a different worldview, one where the human and divine realms were not separate, but constantly interacting. The stones themselves were the bridge. A perfectly cut joint was not just about structural integrity, it was about creating a seamless conduit for spiritual energy. The alignment with a star was not just an astronomical feat, it was an open line of communication. These builders were master storytellers, using the language of geology and geometry to embed their myths directly into the masonry. They transformed functional structures into eternal messages, designed not just to shelter the body, but to elevate the spirit and inspire awe for countless generations to come. These structures have withstood not just centuries, but entire millennia of relentless weather and shifting ground, while many of our modern buildings show significant decay in just a few decades. This incredible longevity forces a direct question. What profound secrets of material science did these ancient engineers possess that we are still struggling to grasp? The Romans famously perfected a form of concrete using volcanic ash, known as pozzolana, which created a chemical reaction that actually allows tiny cracks to heal themselves when exposed to water. But the builders of the great megaliths, who worked thousands of years earlier, achieved a similar permanence without any mortar at all. Their genius was in the dry stone construction itself. The joints between the stones were cut with such impossible precision that they are virtually seamless. This tight interlocking created a powerful mechanical bond, and just as importantly, it prevented water from seeping in. When water cannot pool and freeze inside the joints, it cannot expand and force the stones apart. The choice of stone was equally deliberate. They consistently selected the most durable materials available, like dense basalt and hard granite, stones with a fine crystalline structure that is naturally resistant to wind, rain, and chemical erosion. But the secret to their endurance goes far beyond the materials alone. It is embedded in the very shape of the structures. A pyramid is perhaps the most stable geometric form imaginable. Its wide base and sloping sides distribute the immense weight of the stone evenly down into the earth, allowing it to dissipate the energy of earthquakes rather than fighting against it. The same principle is visible in the curved, earthquake-resistant walls of Inca architecture. In Mesoamerica, builders developed another kind of ancient supermaterial. They created lime plasters and stuccos that were meticulously mixed and applied. Over time, these plasters undergo a process called recarbonation, where they slowly reabsorb carbon dioxide from the atmosphere, causing them to harden and strengthen over centuries, becoming even more resilient than the day they were applied. This stands in stark contrast to modern Portland cement, which often begins to degrade after just a few decades. The lesson these ancient sites teach us is one of holistic design, where the material, the joint, and the overall form work in perfect synergy to create something truly eternal. Their legacy is a masterclass in sustainable architecture, built not for a generation but for the ages. What could we learn if we finally chose to listen to the stones? This celestial precision required a profound understanding of time itself. Ancient engineers were master astronomers, orienting their structures with breathtaking accuracy to capture the solstice sunrise or mark a lunar standstill. The Great Pyramid of Giza, for instance, contains narrow shafts that pierce its massive core, precisely aligned to point toward specific stars like Sirius and the circumpolar stars of Orion's belt. These were not ventilation shafts in the modern sense, but likely channels for spiritual navigation, intended to guide the soul of the pharaoh directly to these eternal, celestial realms. Far across the world, at Chichen Itza in Mexico, this astronomical genius takes a different, equally stunning form. During the spring and autumn equinox, the setting sun casts a series of triangular shadows down the steps of the Great Pyramid, El Castillo. These shadows merge with the stone serpent heads at the base, creating the undulating body of a massive, illuminated serpent slithering down to the earth. This was the feathered serpent god Kukulkan, making his annual descent in a spectacle of light and shadow. How did they achieve such perfect alignments without telescopes or modern computational tools? Their instruments were deceptively simple. A gnomon, essentially a vertical stick placed in the ground, could track the sun's path with remarkable accuracy. By marking the tip of its shadow at different times of day and throughout the year, they could map the sun's journey, identifying the longest and shortest days, the solstices, and the days of equal light, the equinoxes. This was not a project for a single lifetime, but a sacred science built on generations of patient, meticulous observation. Priests and engineers would have maintained detailed records, noting the cyclical patterns of the sun, moon, and planets over centuries. This celestial connection served a dual purpose. On a practical level, it created an agricultural calendar of immense reliability, telling farmers exactly when to plant and when to harvest, which was the foundation of any stable civilization. On a spiritual level, it wove human existence into the grand tapestry of the cosmos. The engineering was not separate from this belief system, it was its ultimate expression. Building a pyramid that pointed to a star, or a temple where a serpent of light appeared on a specific day, was an act of harmonizing human life with the fundamental rhythms of the universe. Their vision saw no division between science and religion, only a unified reality where engineering served to make the sacred visible, tangible, and eternally present in stone. Deep within the granite core of an ancient Egyptian artifact, a silent story is etched in stone. When engineers examine drill cores removed from blocks of granite, they find something deeply puzzling. The walls of these boreholes are not rough or irregular. They are marked by clean, consistent spiral grooves, grooves that run in an unbroken pattern from one end of the core to the other. This is not what you get from a simple hand-powered drill, where the progress would be slow and jerky. This pattern is the unmistakable signature of a drill bit being fed into the stone under immense, consistent pressure, rotating at a high and steady speed. The tool would have had to be harder than the granite itself and driven by a power source far beyond human muscle. This single piece of evidence, preserved for millennia, forces us to reconsider everything we thought we knew about ancient toolkits. It points to the possibility of advanced machinery, perhaps a form of lathe or a drill powered by a complex system of weights and pulleys that has since been lost. The implications are staggering. If they could drill granite with such ease, what other machines might they have possessed? This question finds a startling echo not in stone, but in bronze at the bottom of the Mediterranean Sea. The Antiquity mechanism, recovered from a 2,000-year-old shipwreck, is a corroded clockwork of interlocking bronze gears. For decades, it was dismissed as an incomprehensible object, an anomaly. But modern imaging has revealed it to be a sophisticated analog computer, capable of predicting planetary movements, lunar eclipses, and even the dates of the Olympic Games. It proves unequivocally that the ancient Greeks, and perhaps others, had mastered the art of precision gearing and complex mechanism design on a level that would not be seen again for over 1,000 years. This was not a simple lever or pulley. It was a machine of intricate complexity. If such a device could be built for astronomy, is it so hard to imagine that similar mechanical genius was applied to the problems of engineering and construction? This thread of advanced technology seems to stretch across the ocean to the high plateau of Bolivia. At Puma Punku, the andesite blocks are not merely cut. They are precision-engineered with razor-sharp edges, perfect 90-degree angles, and intricate, recessed channels that interlock like pieces of a grand stone puzzle. Some of these channels are H-shaped and repeated across multiple blocks with a consistency that feels industrial. This level of geometric repetition and perfection suggests something beyond hand carving. It hints at prefabrication, where stones were cut to a master template, a concept that implies standardized measurement and a production line mentality. The stones of Puma Punku look less like they were chiseled and more like they were milled. Even more perplexing are the scattered reports of vitrified stone at certain ancient sites, where the surface of the rock appears to have been melted and fused, as if by extreme heat. While natural events like lightning strikes can cause this, the location and pattern of some findings have led to speculation about the use of directed high-temperature processes, a technology we would not associate with the ancient world. Mainstream archaeology rightly demands caution, attributing these wonders to immense skill and patience, yet the anomalies persist, forming a pattern that is difficult to ignore. They challenge the comforting, linear view of human history where technology progresses in a straight, upward line. Instead, they suggest a different possibility, that human ingenuity has experienced peaks and valleys, that advanced knowledge can be achieved, lost in a cataclysm or a dark age, and then patiently, miraculously, rediscovered millennia later. The true mystery may not be the existence of the stones, but the fate of the minds that knew how to shape them. These colossal stone wonders did not emerge from a vacuum. They were the direct expression of the societies that built them, each powered by a unique cultural engine. In Old Kingdom Egypt, the pharaoh was not just a king, he was a living god, the sole link between humanity and the divine. This belief in a divine monarchy created a hyper-centralized state capable of marshalling the entire nation's resources toward a single, transcendent goal. Building a pyramid was a national project that ensured cosmic order and the pharaoh's eternal life, a purpose so powerful it could command generations of labor. The system was so efficient that detailed records, like the Palermo stone, meticulously chronicle royal quarrying expeditions, giving us a glimpse into the state-sponsored logistics that made such feats possible. This stands in stark contrast to the Neolithic communities who raised Stonehenge. Here, there was no pharaoh, no centralized bureaucracy. This was a communal society, likely bound together by shared spiritual beliefs and cyclical rituals. The motivation to move those 70-ton bluestones from Wales was not a royal decree, but a collective, sacred undertaking that united scattered tribes in a common purpose. Their engineering was an act of communal faith, a physical manifestation of their shared identity. Across the Atlantic, the Inca Empire perfected a different model entirely, one of social duty woven into the fabric of the state. Their mita system was a form of labor tax where every household contributed a set amount of work to state projects each year. This was not slavery, it was a rotational civic duty, a way to pay back the empire that provided security and infrastructure. A farmer might spend a few months helping to build a terrace at Machu Picchu, then return to his fields. This system transformed monumental construction from a crushing burden into a manageable, integrated social ritual. The values of each culture are literally set in stone. The Egyptians, obsessed with eternity and the afterlife, built in timeless geometric forms with indestructible granite, aiming to cheat death itself. The Maya, whose worldview was dominated by vast, repeating cycles of time, built observatories like El Caracol, and encoded their precise astronomical knowledge into their temples, reflecting a universe of eternal return. The environment shaped their methods just as deeply. The Egyptians had the predictable, placid Nile to transport their stone, while the Inca, masters of mountainous terrain, developed their iconic polygonal masonry to withstand constant seismic shocks. Recognizing this context does not diminish their achievements, it elevates them. It reveals that these impossible structures were not built by magic or by aliens. They were built by human societies operating at the peak of their organizational and spiritual power, driven by a combination of religious fervor, political will, and an intimate dialogue with their environment. The stone is the proof, but the culture was the catalyst. Even our oldest stories whisper secrets of these impossible constructions. Long before modern archaeology, humanity preserved the memory of these feats in myth and legend, suggesting the true methods were so extraordinary they passed into the realm of the divine. The Egyptian god Thoth was not merely a deity of wisdom. He was credited as the divine architect who gave humanity the very knowledge of building, of geometry, and of writing. In the Andes, the creator god Viracocha was said to have commanded the stones, shaping them and moving them into place with nothing but the sound of his voice. And in Homer's epic tales, the massive walls of Mycenae were described as the work of the Cyclopes, one-eyed giants of immense strength. This was not just poetic fantasy, it was an attempt to explain the unexplainable, to give a name to the hands that stacked stones no mortal should have been able to lift. These myths may be the most important historical records we possess, not literal truth, but symbolic maps of a lost reality. The renowned scholar of religion Mircea Eliade argued that myths were not mere fairy tales, but sacred narratives that encoded fundamental truths about the world and humanity's place within it. They were a way of transmitting profound practical and spiritual knowledge across countless generations. When a story says a god moved stones with sound, it might be preserving a fragment of memory about a real, if forgotten, technology of acoustic levitation or resonance that reduced friction. When legends speak of a divine teacher bestowing the secrets of architecture, it could point to a historical figure, a genius engineer whose revolutionary methods were so advanced they became immortalized as a god. This pattern is global. The Aboriginal Dreamtime stories of Australia are not just creation myths, they are intricate navigational and geological charts. Specific songs and stories describe how the ancestral beings shaped the landscape itself, creating waterholes and mountains in their journeys. These oral traditions contain precise, practical information about the land, its resources, and its engineering that has been passed down for over 40,000 years. They are a living library of environmental science. So how do we read these ancient codes? The key is to analyze the myth alongside the physical evidence. The legend of Viracocha's voice finds an echo in the acoustic properties of sites like the Hypogeum in Malta, where sound was clearly manipulated for powerful effect. The story of the Cyclopes finds its physical proof in the Cyclopean masonry of Mycenae itself, where the giant, irregular blocks are still called Cyclopean to this day. This blurring of the line between practical skill and supernatural aid was likely intentional. It inspired a potent mixture of fear and admiration, solidifying the power of the ruling class. If a pharaoh could claim direct descent from the god who taught humanity how to build, then his ability to command the construction of a pyramid was not just a political act, it was a divine right. The true identity of the ancient engineer becomes a spectral figure, half human, half god, a master of both the physical and the spiritual worlds, whose greatest trick was to make their supreme skill look like magic. Modern attempts to replicate these ancient engineering feats often reveal more about our own limitations than their methods. teams of archaeologists and engineers have gathered with ropes, wooden sledges, and sheer manpower, determined to prove that primitive tools were sufficient. The results are a mixture of triumph and sobering reality. In a famous experiment for Nova, a crew managed to raise a 35-ton obelisk using a pivoting technique and an earthen ramp. They proved it was physically possible to lift immense weights, yet the agonizingly slow process and the sheer number of people required left many questions unanswered. The experiment succeeded in moving the stone, but it failed to capture the speed and breathtaking precision seen in the historical record. Another team in Japan, using only traditional tools and methods, successfully rebuilt an ancient stone tomb. Their success hinged on a discovery that went beyond simple physics, the critical role of human rhythm. The workers developed coordinated chants and movements, turning a chaotic pull into a single, fluid, mechanical force. This subtle element of coordination, a kind of embodied knowledge, is almost impossible to find in an archaeological dig. It is a living secret, passed from master to apprentice and lost when that chain is broken. These modern endeavors highlight a crucial gap. We focus on the tangible tools, the levers and ramps we can see and hold, but we might be missing the intangible tricks. The ancient Egyptian practice of wetting the sand, once seen as ceremonial, was a masterstroke of practical physics. What other simple, almost invisible techniques have been lost to time? Perhaps it was a specific way of twisting a rope to increase its grip, or a particular rocking motion to navigate a stone over rough ground. Modern replication teaches a profound humility. It suggests that ancient engineers were not just strong, they were smart in ways we are still learning to appreciate. Their methods were not invented in a single brilliant moment, but refined through generations of trial and error, a cumulative wisdom written not in books, but in the successful placement of one perfect stone upon another. The choice of stone was never random, it was a declaration of intent. These ancient builders embarked on epic journeys to source specific materials, transforming the very act of gathering into a sacred pilgrimage. The bluestones of Stonehenge stand as a perfect example. These smaller pillars were not quarried locally. They were dragged over 140 miles from the Preseli Hills in Wales. Modern geochemical analysis confirms this incredible journey, matching the stone at Stonehenge to specific outcrops in the Welsh landscape. But why undertake such a monumental effort? The answer seems to lie in the stones themselves. The Preseli bluestone is a distinctive spotted dolerite, and when struck, it produces a unique metallic ringing sound. This acoustic property may have been central to the rituals performed at the circle, turning the entire structure into a giant, resonant instrument. Furthermore, local Welsh legends attributed powerful healing properties to these very stones. For the builders, the bluestones were not mere slabs. They were a magical resource, a medicine for the land and the spirit, worth any distance to acquire. This same principle of deliberate sourcing is visible in ancient Egypt on a staggering logistical scale. The massive granite blocks for the pharaoh's sarcophagus and the temple columns did not come from the Giza plateau. They were quarried in Aswan over 500 miles up the Nile. How did they move these multi-ton obelisks such a vast distance? The river itself was their highway. They would load the colossal stones onto specially built, giant barges during the annual flood, when the Nile's waters were high and the current was strong. The journey was a feat of maritime engineering and precise timing, a coordinated national effort that turned the river into a conveyor belt for the dreams of gods. On the remote expanse of Easter Island, the iconic Moai statues tell a similar story of connection to a specific place. The islanders did not carve these giants from just any rock. They sought out the volcanic tuff from the quarry at Rano Raraku, a stone that was uniquely soft enough to carve with their basalt tools, yet hard enough to endure once exposed. Each statue was born from the heart of the mountain, then somehow transported miles across the island's rugged terrain to its final coastal platform, or ahu. The quarry was not just a workshop, it was a womb, and the journey of the moai was a ritual of bringing the ancestral spirit to life and walking it across the land to watch over the people. This global pattern reveals a profound truth. The color of the stone, its hardness, its acoustic ring, or its geological origin were all part of a deeper calculus. A red sandstone might symbolize the blood of the earth, a white limestone purity, a black basalt the fertile night. The material was chosen not only for its physical durability but for its spiritual resonance. The entire construction process, from the moment a stone was selected in a distant quarry to its final placement, was a continuous ceremony, a way of weaving the entire landscape, with all its sacred sites and resources, into a single, monumental tapestry of meaning. Their resilience is a testament to a philosophy that saw time not as an enemy, but as a partner in creation. To walk among these structures is to witness a conversation with the elements, a dialogue where every stone was positioned to answer the specific threats of its environment. In the seismic heart of the Andes, the Inca did not build rigid, brittle walls. Their masonry tapers inward, and the stones are locked together in a dynamic, polygonal puzzle. When an earthquake strikes, the energy does not crack the wall in a single, catastrophic line. Instead, it is dissipated through the countless tiny joints, the stones shifting and settling against one another before locking back into place. It is architecture that dances with the earth rather than resisting it. This same principle of intelligent weight distribution is carved into the very form of the Great Pyramid. Its impossibly broad base and sloping sides channel the colossal mass of over 2 million stones down and out into the bedrock, creating a stability so profound it has shrugged off millennia of desert winds and tremors. But the foresight went even deeper. The pyramid's sides are not perfectly flat planes. They are subtly convex, bulging outward at their center by just a fraction. This was a deliberate correction for optical illusion and, more importantly, for the long-term settling of the massive structure. From a distance, the sides appear perfectly straight, a geometric ideal achieved only by accounting for the reality of time and gravity. The choice of materials was equally strategic, a direct response to the local climate. In the arid, rainless environment of Egypt, fine limestone and hard granite could endure for ages with minimal weathering. But travel to the humid, monsoon-drenched landscape of Angkor Wat in Cambodia, and you find a different solution. The builders used a laterite foundation. Laterite is a highly porous, clay-like rock that is soft when quarried from the ground but hardens irreversibly upon exposure to air and sun. It forms a sponge-like base that manages water perfectly, preventing the saturated ground from undermining the delicate sandstone temples above. These engineers were not just building for their own generation. They were planting a forest of stone whose shade they knew they would never sit under. They planned for settling, for seismic shifts, for centuries of rain. This long-term thinking stands in stark contrast to our modern world of planned obsolescence and structures designed for a 50-year lifespan. Theirs was a philosophy of legacy, where the true measure of a building's success was not its immediate cost, but its endurance across countless tomorrows. This profound patience raises a humbling question for our own time. What could we achieve if we, too, built with the distant future in mind? The microscopic marks left on a granite surface are a language waiting to be translated, a silent record of the tools that made them. Deciphering this language demands more than a single expert. It requires a council of disciplines. An archaeologist can date the site, but only a geologist can identify the specific quarry and understand the stone's crystalline structure. An engineer can calculate the forces needed to move a block, but an acoustician might hear the echo of a forgotten technology. This fusion of fields is transforming our understanding. Under high-powered microscopes, the faint striations on an Egyptian sarcophagus reveal a story not of slow, manual grinding, but of a tool moving with consistent, rapid strokes. Three-dimensional modeling software allows us to digitally reconstruct a temple, testing how its unique masonry would withstand an earthquake, revealing the hidden genius of its interlocking forms. Projects like the Giza Plateau Mapping Project employ laser scanners to create millimeter-perfect digital twins of the entire plateau, mapping every crack and contour. This data can reveal subtle patterns invisible to the naked eye, potentially uncovering sealed passages or chambers that have eluded discovery for centuries. This interdisciplinary lens bridges critical gaps. It helps explain why a specific type of sandstone was transported hundreds of miles, not just for its color, but for its unique acoustic properties or its resistance to seismic shock. It models how celestial alignments could have been calculated using simple gnomons and water levels over generations of observation. The collaboration also sparks modern innovation. Engineers studying the self-locking joints of Inca walls have developed new designs for earthquake-resistant buildings. Architects analyze the natural ventilation of ancient structures to create more energy-efficient designs. This approach reveals the most profound truth about the ancient engineers themselves. They were not specialists confined to a single domain. They were holistic thinkers who saw no boundary between the science of materials, the mathematics of the heavens, and the spiritual needs of their people. Their world was an interconnected whole, and to truly understand their legacy, we must learn to see it the same way, piecing together the fragments of their knowledge with every tool at our disposal. These timeless structures now face their greatest threat not from earthquakes or millennia of weather, but from our own time. The very feet of millions of tourists, the corrosive breath of modern pollution, and the relentless greed of looters are slowly eroding monuments that have stood for thousands of years. The Great Pyramid's limestone casing stones are being worn away by smog and humidity, while the ancient city of Machu Picchu has been forced to implement strict visitor caps and designated pathways to prevent the stone terraces from literally being loved to death. Preserving these wonders is a race against time, demanding a delicate and ethical balance. Do we intervene with modern materials that could alter the original fabric of the stone, or do we let nature take its course? The question is fraught with peril, as past efforts have shown. In the 1950s, a well-intentioned project to restore and re-erect the moai on Easter Island resulted in several of the iconic statues cracking under the stress of the new techniques. That failure taught archaeologists a vital lesson in humility, showing that our best intentions can sometimes cause irreversible harm. Today, the focus has shifted to non-invasive technologies. Ground-penetrating radar and laser scanning allow researchers to see deep inside a pyramid or map a wall with millimeter precision, all without ever touching a single stone. These digital archives become a permanent record, a virtual copy that can be studied by generations of scientists long after the originals have faded. Sustainable tourism models are also emerging, where visitor revenue directly funds conservation and limits human impact, yet the core ethical dilemma endures. How do we honor the legacy of these ancient engineers without imposing our own modern footprint upon it? Their work is not a static artifact to be preserved under glass. It is a living lesson in human ingenuity, a testament to what is possible when mind and material meet. Our greatest responsibility is to ensure these stone voices are not silenced, so they may continue to whisper their secrets to the centuries yet to come. The silent endurance of these ancient structures is now speaking directly to modern engineers, offering solutions to some of our most pressing challenges. Today's architects and builders are increasingly looking backward for inspiration, mining the past for sustainable and resilient design principles. In seismic zones around the world, the chaotic, interlocking polygonal walls of the Inca are no longer just a historical curiosity. Engineers now use computer modeling to understand how these jigsaw-like structures dissipate the energy of an earthquake, allowing the stones to shift and settle without collapsing. This ancient wisdom is directly informing the design of modern, flexible building frames that can dance with the Earth's tremors rather than fight them. Similarly, the passive ventilation systems found in the Great Pyramids and in Persian wind catchers are being re-examined. These designs used precise geometry and natural airflow to cool interior spaces without any electrical power, a concept that modern sustainable architecture is eagerly adopting to reduce energy consumption. There is even a race to decode the chemical secrets of ancient Roman concrete, a material that not only lasts for millennia but actually heals its own cracks when exposed to seawater. This cross-temporal dialogue enriches our innovation, proving that brilliant solutions are not always about increasing complexity. The Roman mastery of the arch, a form that efficiently distributes weight, is a foundational principle in countless contemporary bridges and domes. By learning from the past, modern engineering gains both humility and a powerful creative spark. It is a recognition that advanced technology is not always defined by silicon and steel, but can be found in the elegant, efficient solutions honed by generations of human ingenuity facing the timeless challenges of nature. Even with all we have uncovered, the fundamental puzzles remain stubbornly in place. How were the 1,000-ton trilithons at Baalbek ever lifted into position with such perfect alignment? What specific tools created the unnervingly precise, machine-like cuts in the andesite blocks at Puma Punku? These are not minor details, they are gaping holes in our understanding that decades of research have yet to fill. The path forward, however, is illuminated by new and extraordinary technologies. Artificial intelligence can now run millions of construction simulations, testing ancient methods against digital physics to find the one scenario where the impossible becomes plausible. Genetic analysis of the remains found in worker villages near the Giza Plateau can trace the origins of the laborers, revealing the vast trade and tribute networks that fueled these projects. From above, satellites peer down with sensors that see beyond the visible spectrum, potentially revealing the outlines of completely unknown sites buried beneath jungle canopies or desert sands. These are not just tools for finding new ruins, they are keys to understanding the true scale of ancient ambition. The investigation is also turning toward invisible forces we are only beginning to measure. The role of controlled acoustics in construction, hinted at by resonant chambers across the world, remains a fertile ground for study. Could specific sound frequencies have been used to temporarily alter the properties of stone, making it easier to work? Similarly, the subtle magnetic anomalies detected at certain megalithic sites suggest the builders may have been attuned to the Earth's own energies, perhaps using them for alignment or even for purposes we cannot yet conceive. Every answer we uncover does not close the book on these ancient engineers. It simply opens a new chapter filled with even more profound questions. Their enduring allure is not just in what they built, but in their relentless ability to challenge our modern assumptions. They stand across the millennia not as primitive ancestors but as peers, daring us to expand our definition of the possible and reminding us that the greatest discoveries about our past may still be waiting just beneath the surface. That enduring allure of the stones is not confined to history books. It resonates deeply within our modern psyche, surfacing in blockbuster films, best-selling novels, and immersive video games. We are captivated by the mystery of the pyramids, the grandeur of lost cities, and the silent challenge of monolithic statues. This is more than simple entertainment. It is a reflection of a profound psychological need. In a world saturated with instant answers and digital noise, these ancient puzzles offer a genuine, tangible mystery. They connect us to a sense of wonder, to the thrill of an unsolved riddle that humbles our advanced technology. They remind us that long before microchips, human minds achieved the impossible with little more than observation, collaboration, and raw ingenuity. This fascination taps into a deep yearning for connection to something greater than ourselves, to a shared human story of ambition and brilliance. The very fact that these structures resist our full understanding creates a powerful counter-narrative to our tech-driven age. Their low-tech achievements stand as a monumental testament to the fact that true brilliance does not require electricity or a power cord. They whisper a potent message of resilience and creativity, demonstrating that perceived limits can be shattered with enough collective will and clever thinking. A single block moved by 1,000 people is not just a feat of strength, it is a lesson in what humanity can accomplish when we work together toward a common, seemingly impossible goal. This shared wonder fosters a unique global community. Online forums buzz with theories, archaeologists from every nation collaborate on digs, and amateurs analyze satellite imagery, all united by a desire to decode our shared heritage. The psychological impact is a unifying force, breaking down barriers and reminding us of our common roots. Ultimately, these ancient engineers do more than challenge our historical timeline, they challenge our view of ourselves. They force us to ask what untapped capabilities lie dormant within us all, waiting for the right vision, the right challenge to be awakened once more. The secrets of moving mountains were not always written down in books. For countless ancient engineers, their most profound knowledge lived in the human voice, passed in whispers from master to apprentice across generations. This was a world of living libraries where the blueprint for a pyramid or the technique for fitting a stone was a story, a song, or a rhythmic chant. This oral tradition was the backbone of their craft, and its fragility is one of history's greatest losses. When a civilization collapsed, conquered by outsiders or shattered by famine, its entire library of engineering wisdom could vanish in a single lifetime, leaving only the silent stones as a testament to what was once known. The Inca Empire offers a haunting example. They used a complex system of knotted cords called quippers. We know these were not just simple counting tools, they were sophisticated records capable of encoding narratives, laws, and perhaps even the intricate data needed to construct sites like Machu Picchu. But the Spanish conquest systematically destroyed this knowledge, and today, despite our best efforts, we cannot fully decipher the stories those knots are trying to tell. The construction plans for some of the world's most earthquake-resistant structures are locked away in a code we can no longer read. This loss is not just a historical tragedy, it is an ongoing one. In the Highlands of Scotland, the ancient art of dry stone walling, a method of building incredibly durable walls without any mortar, was kept alive for centuries through oral tradition. Master masons would teach their apprentices how to select the right stone, how to shape it with a precise tap, and how to interlock each piece so the wall would stand for centuries. This knowledge was not written in a manual, it was demonstrated, spoken, and felt. Today, ethnographers are working with the last guardians of these traditions, carefully documenting their techniques before they are forgotten forever. These living connections show us that ancient engineering was as much about storytelling and patient mentorship as it was about levers and ropes. A master builder was not just a technician, but a keeper of stories, someone who understood the personality of the stone and the rhythm of the team. This reveals a profound truth about the nature of innovation itself. Our modern world prioritizes the written word, the digital file, the patent. But the ancient engineers remind us that some of the most vital knowledge is embodied, carried in the hands, the voice, and the shared memory of a community. Their silent stones urge us to look beyond our own systems and to value the diverse, intangible wisdom that still exists at the edges of our globalized world before the last echoes of those ancient voices fade away completely. The Roman aqueducts stand as a testament to a different kind of ancient genius, one built on the arch and a revolutionary concrete that could set underwater. While the Egyptians mastered the movement of single, colossal blocks, Roman engineers perfected the art of the span, channeling water across vast distances through elevated channels supported by repetitive, elegant arches. Their challenge was not lifting a 1,000-ton stone, but maintaining a precise, gentle gradient over dozens of miles, a feat of surveying that rivals any celestial alignment. Similarly, the Great Wall of China presents an epic of adaptation. Instead of quarrying monolithic stones, its builders used whatever was at hand, packed earth in the plains, rough stone in the mountains, creating a serpentine fortification that clings to impossible peaks. Its construction was not the project of a single pharaoh, but a cumulative endeavor stretched over centuries and dynasties, a patchwork of organizational models and defensive strategies. These wonders, from the aqueducts to the wall, showcase a universal pattern in human innovation. They all relied on local materials, mobilized vast labor forces through taxation or conquest, and were driven by a long-term vision that transcended individual lifetimes. The Roman concrete was mixed with local volcanic ash. The wall was built from the very mountains it traversed. Yet this global comparison also throws the uniqueness of the megaliths into sharp relief. The Roman arch is a masterpiece of distributed weight, and the Great Wall is a triumph of scale and persistence. But the act of moving and placing a single stone heavier than a jumbo jet, with joints so perfect they deny a razor blade, represents a different pinnacle altogether. It is where unimaginable mass meets impossible precision, a combination that remains one of humanity's most enduring and humbling mysteries. We have journeyed across continents and through millennia, piecing together the secrets of the engineers who moved the unmovable. Their legacy is not merely one of stone, but of the human spirit itself, a testament to the boundless power of creativity, collaboration, and an insatiable curiosity. These enduring mysteries teach us that history is not a simple, straight line of progress, but a rich and complex tapestry woven with countless threads of innovation, some of which we are only now beginning to see. In our own era of global challenges, from climate change to resource scarcity, their ancient example offers a powerful blueprint. They show us the profound strength of thinking holistically, of building sustainably for the long term, and of never, ever underestimating the power of human ingenuity. Let these silent stones speak to you. Listen to their ancient whispers. What incredible wonders could we achieve today if we dared to combine their timeless wisdom with our modern knowledge? The conversation does not end here. Share your own thoughts and theories in the comments below. And if you are captivated by the greatest enigmas of the past, subscribe to continue this extraordinary journey with us.